We're going to pick up with H on page 32, where the introductory video left off. So we're taking a look at combinations of transformations. I see a multiplication times -1, but it's on the inside of f of x. That means it's a horizontal transformation. So we have a horizontal flip or a horizontal reflection. And then I see a +3 on the outside, plus that affects a shift, and it's on the outside, so it's going to be a vertical shift. So a vertical shift or a vertical translation, and that will be up 3. Now, if you do want to create a table of values, you certainly may. If we want to go through all of the transformations in the table, we're going to pick an x value, and then we are going to take its opposite, and then take f of that value. Function evaluation comes next, and finally add 3 to that. We'll also have to deal with domain here. So our domain for f of x is the interval between -2 and 3. So for f of -x, our input changed. So that means that -x is somewhere in between -2 and +3. If we divide through by -1, that gives us 2 is greater than or equal to x, which is greater than or equal to -3. So I'm going to start with -3 and -2, -1, 0, 1, 2. When we take the opposites, that will give us the values in the next column, and then take f of each of those values. Now, f of each of those values can be read from the graph. F of 3 is -1. F of 2 is 0. F of 1 is 3. F of 0 is 2. F of -1 is 0. And finally, f of -2 is 1. And in the last column, we're just going to add 3 to all those values. -1 plus 3 is 2. 0 plus 3 is 3. 3 plus 3 is 6. 2 plus 3 is 5. 0 plus 3 is 3. 1 plus 3 is 4. Now I can graph each of the points. -3, 2. And -2, 3. -1, 6. 0, 5. 1, 3. And 2, 4. When you connect these points, we ought to see the same exact shape as the other function, but we have a horizontal flip and the graph is shifted up 3. In the next, we can also create a table of values, but if we identify the transformations that should be happening, I see a multiplication by 2 on the outside of the function, so this would be a vertical stretch by a factor of 2, and I see a -1 on the outside of the function, so this will be a vertical shift down 1. And if you want to create a table of values for this, you certainly can. Thinking about order of operations, we are plugging in x values and then taking f of those values and then multiplying those by 2. And then last column here would be 2 times f of x minus 3, subtracting 3 from all of those. Since the input for the function is not changed, the domain can remain the same, which is x values between -2 and +3. f of those values can be just read from the graph. F of negative 2 is 1. F of negative 1 is 0. F of 0 is 2. F of 1 is 3. F of 2 is 0. F of 3 is negative 1. Finally, the last two columns just perform those operations. So we're going to multiply all the values by 2. And then subtract 3 from each. And now we can graph our points, negative 2, negative 1, negative 1, negative 3, 0, 1, 0, positive 1. Be careful with negatives and positives. I still have to be very careful as I plot. 1, 3, 2, negative 3, and 3, negative 5. Let's connect those points in order here, and we're going to see that vertical stretch by a factor of 2, and we also see that shift down, down 1. And I did a shift down 3. Let me fix that. I changed a number at the last moment. This should have been down by 1, so the last numbers in this column should be just subtracting 1. And now I'm going to graph each of those. And now we can see that vertical stretch, and we can also see the shift down 1. Notice that all the points that were on the x-axis are just shifted down 1. They didn't get stretched because their y values were 0, and 0 times 2 is still 0. Let's do one last one. Y equals negative f of x plus 4. Since I see a negative 1 being multiplied to the outside of the function, this represents a vertical reflection or a vertical flip, and plus 4 added to the outside, that means a shift or a translation up 4. If we want to create a table of values rather than relying on those transformations, we're going to take our x values, take f of those x values, then multiply those by negative 1, and finally add 4 to that value. Since the input is not changed, we don't have to think about domain. We can use the same domain or x values that are in the original function. And the function values can be read from the graph. F of negative 2 is 1. F of negative 1 is 0. F of 0 is 2. F of 1 is 3. F of 2 is 0. F of 3 is negative 1. Now we're going to take the opposite of each of those and add 4 to each. Now let's graph each of the points. Negative 2, 3, negative 1, 4, 0, 2, 1, 1, 2, 4, and 3, 5, and connect those points in order, and we will see that vertical reflection and a shift up 4 as well. All right, the last part of this lesson is about piecewise functions. Piecewise functions are functions that are defined on a sequence of intervals. For instance, the absolute value treats different numbers differently. So if I take the absolute value of a number, and that number is greater than 0, I don't do anything to the number. That is to say, when I take the absolute value of a positive number, it's just the same number. When that number is 0, the absolute value is equal to 0. And then when that number is less than 0, that means a negative number. I take its opposite to get the absolute value. So that is one function that can be defined piecewise. And here is another function that is defined piecewise. F of x is 3x plus 2 for x that is less than 0. F of x is 2x minus 1 for x between 0 and 3, inclusive at 0, not inclusive at 3. And f of x equals x plus 1 when x is greater than or equal to 3. So we're just going to keep in mind where our x value is, and the piecewise function will tell us what to do with that x value. So f of 2. So where does 2 fall? 2 is a number that's between 0 and 3. So I'm going to use f of x equals 2 times x minus 1 to find the f of 2 value. So 4 minus 1 is 3, and f of 2 is 3. Now let's take a look at f of negative 3. Where is negative 3? Negative 3 is less than 0, so f of negative 3 is 3 times negative 3 plus 2. We'll use f of x equals 3x plus 2 for any values of x that are less than 0. So that will give us negative 9 plus 2 is negative 7, so f of negative 3 is negative 7. Now let's compute f of 0. So where is 0? Well, it's on the borderline of two of those intervals. But you'll notice that the first interval, for x less than 0, does not include 0. So we're going to use this interval right here that includes 0. So f of 0 will be 2 times 0 minus 1, which is 0 minus 1, or negative 1. And lastly, f of 5. So 5 is a number that is greater than or equal to 3. So we're going to use f of x equals x plus 1. So f of 5 equals 5 plus 1. And that means that f of 5 is equal to 6. It's your turn to try. Here's a piecewise function. Find g of 3. Make sure that you pause the video while you do this. You should have found that g of 3 is equal to 15. And we use g of x is x squared plus 2x because 3 is greater than 1. Now try b on your own. Pause the video while you do this. You should have found that g of 0 is equal to 5, and we use g of x is x plus 5 because 0 is a number that's less than 1. Now try c. Pause the video while you do this. For this value, even though 1 is at the border of the two intervals, the first interval, x is less than or equal to 1, includes the number 1. So g of 1 is 1 plus 5, or g of 1 is 6. Now try the last one on your own. Pause the video while you do this. The last value here is g of negative 3 is equal to 2. And since negative 3 is less than or equal to 1, we use g of x equals x plus 5. Now in the next example, we're going to graph each piecewise function, and I suggest that we do this using a table of values. However, I'm going to use two tables of values, one for each piece. So, for the first table of values, we have x and y equals negative x plus 1, but I'm going to do this table of values for x's that are less than or equal to 0. So I'm going to start my interval with 0 and move into a direction that is less than. So 0, negative 1, negative 2, negative 3, and we could keep going, but we won't. So if x is 0, then y is negative 0 plus 1, which is 1. If x is negative 1, take the opposite of the x value and add 1. That'll be 1 plus 1 is 2. And the opposite of negative 2 is 2, plus 1 is 3. The opposite of negative 3 is 3. 3 plus 1 is 4. So what this gives us is 0, 1, negative 1, 2, negative 2, 3, and negative 3, 4, and the graph keeps going, and we can see that this is going to form a straight line here. So I'm just going to continue the graph and indicate an arrow. Now I'm going to create a second table for x greater than 0. And so for this table, y is equal to x minus 3, because when x is greater than 0, h of x is x minus 3. So you might think that I wouldn't start the table with 0. However, I will start it with 0 because x is just greater than 0. It doesn't mean that we start at 1. It means that we start at a number that is just a little bit greater than 0. So I'm going to start at 0, but when I graph this point, we'll have a special graph feature here. 0 minus 3 is negative 3. Now 1 minus 3 is negative 2. 2 minus 3 is negative 1. And 3 minus 3 is 0. And we could keep going, but we won't continue that table. We'll just indicate that the graph continues from there. What I'm going to note here is that since we can't include x equals 0 in this interval, we'll graph an open circle at this point. So instead of the solid circle that we made in the first interval, we're going to make an open circle at 0, negative 3, and then 1, negative 2, 2, negative 1, 3, 0, and the graph keeps going. So we see that we have an open circle on one endpoint of the graph and a closed on the other. Let's try a piecewise function that has 3 pieces. So I'll make 3 tables of values for this. The first interval will be x is less than 0, and our table is x and x squared. So again, I want to start with 0 and then move in a direction less than. So if x is 0, x squared is 0. If x is negative 1, x squared is 1. If x is negative 2, x squared is 4. If x is negative 3, x squared is 9. And since the interval did not include 0, I'm going to indicate an open circle on that point right there. So 0, 0, we have an open circle. Negative 1, 1, negative 2, 4, and negative 3, 9 will not fit on my graph, but I know what this looks like. This is that characteristic parabola shape, but I'm only seeing 1/2 of that parabola. For the interval between 0 and 2, I'm going to graph y is equal to 1/2 times x minus 1, and I'll use 0, 1, and 2 as points. We need to include the endpoints here in our table, even though the endpoint is not included in the interval. So 1/2 times 0 is 0, minus 1 is negative 1. 1/2 times 1 is 1/2, minus 1 is negative 1/2. 1/2 times 2 is 1, minus 1 is 0. But note that we're starting again with an open circle on that endpoint, and we have a closed one on the other endpoint because 2 is included in that interval. So 0, negative 1 has an open circle. 1, negative 1/2 is included. 2, 0 is also included, but that's an endpoint of the interval. So really that's just the piece of that piecewise function. And then for our next table, that would be the interval from 2 to 5. We have our x values, and our y values will always be negative 2. So our x values range from 2 to 5, 2, 3, 4, 5, and the y values are always negative 2. So 2, negative 2, and that one is not included, so that's again an open circle. 5, negative 2, that would be our other endpoint, will be closed because x equals 5 is included in that interval. So 2, negative 2, open circle. 3 comma negative 2, 4 comma negative 2, 5 comma negative 2. That's our other endpoint of this interval. And there's our piecewise function. And one last to try here. So this is again 3 pieces. Our first interval is x is less than or equal to negative 1, creating a table of values. Our x values and our y's are just the same as the x values. So negative 1, negative 2, negative 3, negative 4. I could keep going, but I won't. And the y values are the same as the x values. And what I will notice is that the endpoint of the interval x equals negative 1 is included, so that will be a closed circle. So negative 1 comma negative 1, negative 2 comma negative 2, negative 3 comma negative 3, negative 4 comma negative 4, and the graph keeps going. Now let's graph another interval. This would be the interval from negative 1 to 2, and we'll plug in our x values, negative 1, 0, 1, and 2, and our y values are always 3. By the way, this one, neither endpoint is included. We don't have or equal to's in that interval right there, so both of these endpoints of this interval will be open circles, indicating that the point is not included in the graph. So negative 1 comma 3, open, 0 comma 3, 1 comma 3, 2 comma 3 is also open, so the endpoints of that interval are not included. And lastly, one more table for x is greater than or equal to 2. And if x is greater than or equal to 2, we'll start with 2, 3, 4, 5. I could keep going, but I won't. And our y values are negative x plus 5. So negative 2 plus 5 is 3, negative 3 plus 5 is 2, negative 4 plus 5 is 1, negative 5 plus 5 is 0. And the endpoint of this interval, x equals 2, is included. That will be a closed circle in the graph. So 2 comma 3. And what you'll notice about this one is that's going to fill in that open circle. So the open circle is not there anymore because the point 2, 3 is included. And then 3, 2, and then 4, 1, and 5, 0, and the graph continues in that direction with an arrow on the end. So you'll notice there's actually only one point of what we call a discontinuity in this graph because our two pieces did meet up at 2 comma 3. All right, you have one to try on your own. Pause the video while you do this. Here's the graph. You'll notice that it includes some lines, and it also includes one of our parent functions, the square root parent function. We have one more example here. That is, given the graph of a piecewise function, we're going to write its equation. So what I'm going to notice about this is that there are 3 pieces to graph here. Our first piece has x's that are between negative 4 and negative 1. So I'm going to write the words 4, and negative 4 is less than or equal to x, which is less than or equal to negative 1, to represent these two endpoints of the interval. The next thing that I'm going to do is I'm going to take and I'm going to draw an extension of this line right here, and we're going to notice something about this line. If I extend it, it would go through the y-axis at a y-intercept of 1. So that's the b value in y equals mx plus b. Also, I'm going to notice that its slope is equal to negative 1. So now I have its slope and its y-intercept, so y equals negative x plus 1, or negative 1x plus 1. Notice that I don't write y equals because y equals is over here on the left side of that curly brace. All right, I'm going to get rid of my drawing on top of that graph, and now we're going to focus on piece number 2. So piece number 2 is between x equals -1 and +2. Now, at -1, the two pieces met up. So we could include that endpoint in either one of the two pieces, but not both. So I'm not going to include -1 in this piece. It's a personal choice. You can include it in piece number 1 or piece number 2. It doesn't matter. So -1 is less than x is less than less than 2. And the reason that I'm using less than for x equals 2 is that the graph has an open circle there. What I will notice about this particular graph is if I were to extend this piece, it forms a horizontal line, and the graph of a horizontal line is represented by the equation y equals a number and y equals 2. So h of x equals 2 for x between -1 and +2. And now we have a last piece of the graph to use here, and this piece of the graph has a closed circle here at +2 and proceeds to the right with an arrow on the end. So this last piece is for x greater than or equal to 2. What does this graph look like? If I extend the graph, it would have a y-intercept of -4, and it would have a slope of 1. So the equation is y equals 1x minus 4, or just x minus 4. Notice again, I did not include the y equals because y is h of x, which is on the left side of the curly brace. And that's it. Now try the next one on your own. Please pause the video while you do this. Here's the equation for this piecewise function, and that's it for this lesson.